Good morning, this is Alex, your favorite teacher in the whole world. Today we're going to talk about similar shapes and scale drawings. Similar shapes and scale drawings. Well, scale drawings is, we use them all the time in real world, especially a lot of it in construction, a lot of it when designing different things. And the way that goes is that, especially like you might have some of the things that have the scale factor written into it. Like if you buy a Hot Wheels car, if you flip it upside down on the bottom, it says a scale ratio or a ratio of, I don't know, 32 to 1. That means that the actual car is 32 times as big as the Hot Wheel. Also in blueprints, whenever you have blueprints on the lower right corner, there's gonna be a section designed with all the information about the blueprint that you need to know. Who did the blueprint? Does anybody know what a blueprint is?
Yes.
What is it?
Like it's like a map of what the company gonna do.
Okay, yeah, it's kind of like a drawing, maybe of a house, a drawing of a house or a construction or something, a building, something like that. And what that is, somebody does a drawing, but of course, whenever you draw, you cannot draw the actual size of what the building is gonna be. So they're gonna make it on a piece of paper, and then on the bottom, it's gonna say every 1 inch if you measure every line, 1 inch is gonna equal to, I don't know, maybe 6 feet, 7 feet, or whatever. So that means whenever you go to the construction site, you see these guys, the engineers or the architects, rolling up pieces of paper, and they're looking at the drawings, and that's what they're gonna get the materials and everything based on that. So they're gonna see, okay, we're gonna have to build a wall that says the measure is 3 inches, and every inch is 5 feet, so the wall has to be
5 feet.
They say 3 inches. Every inch is 5 feet. So how long is the wall have to be? The actual wall. What is it? 15. All you have to do is multiply. All you have to do is multiply. If you're going from small to big, you multiply. And if you're going from the actual wall to the drawing, you divide. That's all it is. So right here we have the dimensions of a scale model or a scale drawing are related to the actual dimensions by a scale factor. This is a keyword. The scale factor is also called the ratio. And there's 3 ways to write the ratio. As a decimal, using the colon, or using the word to, T-O. It says the length of the model car is 9 inches. So let's say that you have a little model car, the ones that you see a lot of in the gas stations. It's about 9 inches, about this big, right? And it says the length of the actual car is 162 inches. So all you're doing is writing a fraction, 9 inches over 162 inches. Both of them are multiples of 9. That's where they divide by 9. So that means that the scale factor of the model car is 1 to 18. That means that the actual car is 18 times as big. You're multiplying, not 18 inches bigger, because it's not 18 inches bigger. You're multiplying 9 times 18, which will give you 162 inches. Now, that can be simplified. So you have 9 over 62 can be simplified to 1 over 18. We already know how to simplify. Remember, just like at the last week, all we're doing is dividing by a common factor. It says, if you know the scale factor, you can use a proportion to find the dimensions of an actual object or a scale model drawing. So for instance, we have the scale factor of a model train is 1 over 87. A model train, you've seen those, right? A lot of people collect them.
Oh, Mr. Friend.
A piece of the track, okay, this is the scale factor, 1 over 87. It says a piece of the track in the train set is 8 inches long. What is the actual length of the track? So if you compare it, 1 over 87, we can set up our proportions like we did with the tick marks before. So this is the actual scale factor right now. And what are they? Is the top? This one is gonna be what? The real one or the model? The top. The top is gonna be the model, right? So you can label it as well. So this is gonna be the model one, and this is the real one. And then it says the model train is the track in the model train is 8 inches long. Where do you think is that gonna go? On the model or the real one? On the model. So you just put it on top, and on the bottom is gonna be X. You do cross products, and you're gonna get that the real track is gonna be 696 inches long. And then on the test, they might ask you, okay, convert that to feet. Then you're gonna have your conversion sheet. Every 12 inches is 1 feet, and those are also ratios. Okay. So right here you do cross products, so you're gonna have X equals 87 times 8, and you should get X equals to 696, which is that number right there. Now, in Google, when you open Google Maps, you can zoom in and zoom out, right? Yes?
Yeah.
Have you seen at the bottom right corner, you have 2 lines. One arm for miles and another one for kilometers. And as you zoom in and out, those lines change the size. You noticed that before, right?
Yes, sir.
Because that's changing the factor, the scale factor. So right here it says, the distance between 2 cities on a map is 4.5 centimeters. Now we're using centimeters. The map scale is 1 centimeter equals 40 inches. 1 centimeter equals 40 inches. So what do you think you're gonna have to do? 1 centimeter is 40 inches. The distance is 4.5 centimeters. What do you think you're gonna have to do to find how far apart the city is? Multiply. What do you multiply? 4.5 times 40. You set up your proportions. The distance on the map, see, they labeled it, right? Just like I did before, model and real one. Distance on the map is 1 to 40, and it's right here. And the actual distance, and whatever you have 4.5 centimeters equals X. You do cross products, so the cities are 180 miles apart. You're doing cross products, multiply and divide. That's all we're doing. They set up your proportions, and you multiply like that, and if you need to divide, you divide. In this case, we don't need to divide because 1x equals x, right? Just like on that one, 1x was just x. If you add a number next to it, then you divide. So let's do this 4 examples real quick, and you have this paper with you. So make sure you write in this. These are going to be your notes. Now, number 1. Identify the scale factor. We're just going to identify the scale factor. We don't need to know the new measurement or anything like that. It says the photograph height is 3 inches. So they're going to make a photo to a big painting. They're going to take a photo to a big painting. It says, and the painting height is 22 inches. All you have to do is label it, which is already done for us. Photo height, painting height. We have the 2 heights. Label it. So photo height is what?
3 inches.
3. And the painting height is?
20.
Can we simplify that?
Yes.
By what?
8.
By what?
3.
By 3. 3 divided by 3 is? 1. 24 divided by 3 is?
8.
That's my scale factor. 1/8. You can also write it as 1 column 8. Or you can also write it 1, 2, 8.
Or
Those 3 ways are correct. Identify those. Remember those 3 forms. Now, number 2, butterfly. It says a wingspan is 20 centimeters. That means whenever they open the wings, the distance from tip to tip is going to be 20 centimeters. Silk butterfly wingspan. So they're going to make a silk butterfly. It's going to be, the wingspan is going to be 4 centimeters. So they're going to make it a smaller, right? Silk butterfly is what?
4.
4. And the real butterfly is? 20. Can you simplify that?
Yes.
By what?
5.
By 4. Divide by 4 both sides, right? I mean top and bottom. So it's going to be 1/5. How else can I write it? And then 1, 2, 5. I mean. Questions so far? It's easy stuff, right? Repetitive stuff that we have been doing. Now 2 more. We don't have anything set up for us. We're going to have to set it up ourselves. It says, on a scale drawing, the scale factor is 1 to 12, keywords. A plum tree is 7 inches tall on the scale drawing. The plum tree is 7 inches tall on the scale drawing. What is the actual height of the tree? So this is the drawing over the actual. Can we label it like that? Drawing over the actual. And we can set up with whatever I have already. 1 over 12. That's what I have. The drawing is 1 inch, and the actual is 12 inches, or 12 feet. I don't know what this is. Now, equals to, what am I given? Plum tree is 7 inches tall on the scale drawing. What is the 7 gonna go, top or bottom? Top, because I have the drawing on top, right? That's 7, and I'm looking for x. So 1x equals to 12 times 7, which is what? 60 and 24 is
1
84?
Yeah.
So x equals 84.
Divided by 1.
That's it. So it says that the tree is 84 inches. What is that in feet?
8.
7 feet.
7 feet. You might be asked that question. And the last one, on a road map, that's kind of like the example on top, right? On a road map, the distance between two cities is 2.5 inches on the map. The map scale is 1 to 30. What is the actual distance between the two cities? So we're gonna have the map over the actual. Everybody agrees?
Yes, sir.
So we're gonna set up whatever I have already, 1 to 30. Where the 1 goes? Top. And the actual is 30 miles, right? 1 inch to miles, to 30 miles. Equals to, what else am I given? The distance on the map in inches, right?
Yes.
Is that top or bottom? Top. So it's gonna be 1x, or x, equals to 30 times 2.5. What's 30 times 2.5? It'll be 75, if I'm not mistaken. So the two cities are 25 what? Huh? How far apart are they?
75 inches.
75 inches apart, really. And look, you can label this. You have inches. You have inches and you have miles. So the cities are 75 miles apart. Any questions?
Can you go back up?